In this video, we'll talk about role of modeling and expanding testing results during new application development. My name is Boris Zabitsker. I'm CEO of BZNext.
And my name is Alex Padelka. I'm doing performance testing and optimization for Oracle, and I am a board director at Computer Measurement Group.
We're going to talk about problem and role of testing during application development cycle. We'll talk about value and limitation of performance testing and role of modeling optimization, expanding results obtained during testing of new application during DevOps cycle.
Traditional load performance testing was focused on handling peak load by the system and usually happened in the last step before deploying in production during waterfall development process. Things change, and now with DevOps, we need to get feedback earlier. As we see on this graph, the cost of fixing defects skyrocket if that defect is found later in the cycle, as we see. Even if we find it during system test, it is 40 times more expensive to fix it. So our goal to find all performance defects earlier in the cycle. There are many load testing tools around, including commercial, open source, and some combination of both. They have quite different functionality and may be useful for different contexts. In some will help more with to integrate performance testing with DevOps cycles. Some need a lot of additional plumbing work. With all these new options for performance testing, testing strategy become very non-trivial. We have a lot of challenges, including different options along many dimensions of performance testing. It's defined by context, so it no single recipe for that. And automation is only one part of it. It is very important for iterative development, but it is just a part of performance engineering strategy. Before you define your strategy, you need probably to formulate and answer a question on what actually you want to achieve. Today's performance testing brings a lot of value. It is proactive way to mitigate performance risks, and it allows to identify and fix performance issues earlier. But it has its own limit. It is expensive on high scale tests, and if we do it early, it probably will provide partial information without a holistic view of the system. And here modeling could help us, complementing performance testing to mitigate these limits.
During DevOps process, application developers going through planning, designing, coding, development, testing of new application. Operations at the same time involved in verification of testing results, releasing new application, then deploying and operating. And all this continues multiple times, and every time after every major step, testing is performed, performance testing. We use results of performance testing as input to our model in order to evaluate different scenarios, predict how new application will perform in production environment, identify anomalies, root causes, develop proactive recommendation on what should be tuned right away, predicting how new application will affect existing application production environment, and developing recommendations what should be done proactively to be sure that new application will have enough resources, right workload management parameters, and to be sure that the application will perform well, satisfy business requirements in the future. It provides value for application developers and operations. Let's review 10 major steps performed during construction models and usage of the models from performance assurance point of view. Performance modeling and optimization engines use information extracted during stress test, during performance test, and also information about assumptions about workload growth, other assumptions, and all this information used to predict how new application will perform in production environment. The first step in preparing model is data collection on test environment when new application is being tested, and in production environment when many production applications compete for resources. This information characterizing performance, response time, and throughput, usage of resources, CPU, I/O, memory, network, and pattern of accessing data used as input for workload characterization. During workload characterization, automatically performance, resource utilization, data use profile for each application is built. For example, this is information about CPU utilization by each production workload during 24 hours during typical day. In a test environment, we have example of CPU utilization by different modules of new system going through design, development, and testing on a small test environment. The fifth step is anomaly and root cause determination. So after every build, performance test is performed, we collect measurement data and detect anomaly, especially severe anomaly, identify the root causes, and provide information for application developer for immediate tuning of application going through design and development. Fourth step is workload forecasting. Workload forecasting for both existing production workloads and new applications which will go to production. In workload forecasting, based on analysis of historical data or information from the business plan, document expected increase in number of users and volume of data. As we can see, number of users, workload activity for different applications have different growth rate. This information is used in order to build models. And first of all, we build model of production environment. This model is showing what will happen with response time for each production workload during next year, month by month, and predict when existing production workloads will violate service level goals. After that, we, during sixth step, predict the impact of new application implementation. And you can see on this graph, after implementing new application, response time for existing application will be increased. And very soon they will violate service level goals. Our seventh step is predicting the impact of possible workload management optimization changes priorities or concurrency or resource allocations for all existing workloads, new production application after implementing. And the seventh step is predicting the impact of workload management optimization, predicting the impact of the different changes of priorities or concurrency or resource allocation for different workloads. And we can see that implementing recommended workload management measures will improve response time, but not for too long. And hardware upgrade will be required. So eighth step is predicting what is the minimum on-prem upgrade required if you implement new applications on-prem. Of course, it will increase contention for resources and will affect response time for existing and new application. And the question is, how much additional resources will be required? And according to our model, in order to provide satisfactory performance, to be sure that response time will be below service level goals, at least 14 nodes will be required in the middle of the next year. 40 nodes, it's pretty expensive. What are the options? Another option is to use other different platforms. For example, during ninth step, we will analyze what will be the impact of deploying new applications, not on production, on-prem workload, but in the cloud. So modeling, performance optimization is used in order to evaluate different cloud options and determine which cloud will provide sufficient scalability and using elasticity will be able to support service level goals for all workload, for new and maybe existing workloads with lowest cost. So we develop recommendations, and after implementing these recommendations during 10th step, our technology allows to compare automatically collected measurement data characterizing performance of all applications after implementing our changes and compare them with expected results. And if actual measurement results exceed expectations, this is anomaly. So we perform root cause analysis determining what are the reasons why actual usage of resources or performance of this application exceed our expectations. So in a way, this is creation of the closed loop performance assurance process. So in summary, we discussed how to collect measurement data during performance testing to identify and fix performance problems for new applications prior to their deployment in production. We discussed how to build and use models to predict the impact of new application implementation and production, and develop proactive performance tuning, workload management, and capacity planning recommendations focusing on how to consistently support business needs in terms of service level goal, in terms of response time and throughput for all of the growing workloads with the lowest cost. So as we can see, modeling complement performance testing and allow to address a variety of what-if questions, compare options, and develop valuable proactive recommendations for application developers in operations to mitigate performance risks, avoid performance problems, and provide consistently acceptable performance for new and existing workload in selected environment. Thank you. And if you have any questions, please use our emails and your questions. I'll be happy to answer.